Alright, so I just wanted to take a video to explain the different types of bonding methods. Covalent bonding, ionic bonding, and metallic bonding. These three bonding methods are very common, but it's also very easy to get mixed up between the three, so it's very confusing. First of all, let's start with covalent bonding. Covalent bonding is the bonding between nonmetals and nonmetals. So it's nonmetals. I'll explain why this is in just a moment. Ionic bonding is between metals and nonmetals. So it's from a metal to a nonmetal. And metallic bonding, as the name suggests, is metals. So before we go into what covalent, ionic, and metallic bonding is, let's just think about why this would happen, right? So all these bonding techniques happen so that these atoms can have a full outer shell of electrons. Because all atoms want to have a full outer shell in order to become stable, right? Until they have a full outer shell, so no valence electrons, they're unstable and they're unreactive. So in covalent bonding, the atoms share electrons. They share electrons together. They're not actually giving away any electrons, they just share electrons. So they're just sharing the electrons together. So that would mean there's no charges because you're not actually losing or gaining any negative electrons. In ionic bonding, you're actually giving away or receiving, electrons. So that means there are charges. So they form ions because remember, ions are just charged atoms. Metallic bonding is a bit confusing, but essentially they don't really give or lose electrons. There are just delocalized electrons. And they do sort of form charges. So I guess they do sort of form ions. So let's look at what covalent bonding is first. Covalent bonding, as I said, is the sharing of electrons between nonmetals, right? So why would nonmetals want to share electrons? Well, nonmetals are on the right side of the periodic table, right? So they're gonna be in either groups 5, 6, or 7. Because remember, group 0 has a full outer shell. So they're either gonna have 5 electrons, 6, or 7 valence electrons. So for that, it's gonna be much easier for them to receive 3, 2, or 1 electrons than get rid of their electrons that they already have a ton of, right? So they just want to share electrons together between the electrons that have a lot of it. So for example, chlorine, which is in group 7, has 7 electrons. 1, 2, 3, 4, 5, 6, 7. Chlorine has 7 electrons in its outermost shell. That's why it's in group 7. Now it can bond with another chlorine atom, which is also going to have 7 electrons, right? And we show the other chlorine atom's electrons by using these dots. So this is called a dot and cross diagram. And this chlorine atom has 7 electrons, this chlorine atom has 7 electrons, so they can share 1 electron each so that they both have full outer shells becoming unreactive and becoming stable. So both of these chlorine atoms have full outer shells. Now covalent bonds form covalent compounds. Now when covalent bonds form covalent compounds, they're going to form different types of substances. So they don't exactly form covalent compounds, they form different types of substances. So they can form simple molecular substances. Which is kind of like these two chlorine atoms here forming a molecule. So it's a simple molecular substance. So chlorine covalent bonds can form simple molecular substances. And they can also form giant covalent bonds or giant covalent substances, which we will look at in the next video. Now, ionic bonding is from a metal to a non-metal, right? So metals are on the left side of the periodic table, right? So they're going to have a few electrons. They're either going to be in groups 1 or 2, the halogens, or group 2. So that means they have 1 or 2 valence electrons. It's going to be much easier for them to just get rid of those 1 or 2 electrons, right? So that's why metals want to give away their electrons, and non-metals, as I aforementioned, they're on the right side of the table. They want to receive electrons, right? So they can sort of have a symbiotic relationship. Metals want to lose and non-metals want to receive. So the metals give away electrons and non-metals receive these electrons. And they form ions. They form charges because electrons aren't being shared. They're actually given or received. So that's going to form charges, right? Because electrons are negative electrons. When you lose them, you're going to become a positive ion, and when you receive them, you're going to become a negative ion. So what ionic bonding is for example, sodium. Sodium has 1 electron in its outermost shell. So it's going to have 3 shells. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Up to here, the shells are full, but the outermost shell has 1 electron. We're not going to draw the outermost electron, but we are going to draw these brackets to show that sodium becomes an ion, and sodium is a metal, right? And it's going to share some electrons with a non-metal called chlorine. Chlorine also has 3 shells. And like before, we're going to draw chlorine's electrons using dots so that we can differentiate the electrons and we can tell where these electrons are moving. And chlorine has 7 electrons in its outermost shell. And what can happen is the sodium is going to have 1 valence electron, right? It's going to give one of its valence electrons to sodium and this to chlorine, sorry. And the sodium atom is going to form a positive 1 plus positive ion because it lost 1 negative electron. And this chlorine atom is going to form a 1 minus negative ion because it just received 1 negative electron. That's ionic bonding. And ionic bonds form ionic compounds. Okay. Metallic bonding is between metals. And metals, the thing about metallic bonding is a bit interesting. So atoms have electrons in their shells, right? But how metallic bonding is imagine this is the universe, for example. And let's say we have solid metal. So this is an enlarged image of a solid metal. And solid metals are going to have atoms like so, right? So if you watched my previous video, you'll know that atoms have a positive nucleus because in the nucleus there are protons and neutrons are neutrally charged, so they don't really make a difference. But there's protons in the nucleus, so these atoms, the nucleus is positively charged. Now surrounding the nucleus we should have negatively charged electrons. But what happens with these metallic bonding is that the electrons, they aren't stuck to one atom. If we look at both of these examples in covalent bonding, these electrons are stuck to these chlorine atoms. Although they're being shared, they're still stuck between these 2 chlorine atoms. They're not free to move around different chlorine atoms. And same with sodium and chlorine. These electrons are just being moved from this sodium to this chlorine atom. They're not free to move around or just go anywhere. But what happens in metallic bonding, so between metals, is that these electrons that are negatively charged, they are shared between all these electrons. All these atoms. All these positively charged nucleuses, all right? They're going to be attracted to these negatively charged electrons in something like this. So a positive nucleus is attracted to a negative electron, which is also attracted to another positive proton, which this is also attracted to another positive proton, and this is attracted to another negative electron, and this is attracted to another positive proton, like so. So the electrons are free to move around. We call them delocalized electrons. So localized would be being local to one thing, right? Delocalized means they're free to move about. So these electrons are delocalized, and they're free to move about different atoms. Now, just to be clear, these atoms do have nucleuses, electrons of their own. These electrons are just the outermost valence electrons. These valence electrons are free to move about, and they can move about different atoms and form bonds between them. So yeah, that's what metallic bonding is. These electrons, delocalized electrons that are free to move about. And of course, these are going to form ions because these electrons aren't stuck to this atom anymore, right? So these atoms are going to have positive charges. And metallic bonds, the thing about metallic bonds is metallic bonding is between metals, right? The reason they can conduct electricity, so metals conduct electricity, right, is because these electrons are delocalized. And that's pretty much all you have to know about covalent, ionic, and metallic bonding. I hope you understand the differences between the 3 now.